Okay, so hello everyone. Let's wait for a few more seconds until the rest of you will join, and then we can start. Okay, so let's start. Welcome everyone. I will talk about myself in like one slide, but this webinar basically was meant to talk to you about landing zone and specifically how you deploy the landing zone as a code. So let's just dive in without further ado. So first of all, about myself, my name is Vaknin. I'm a senior consultant here at TerraSky, working since 2015, so like 7 years now. I came from an IT and virtualization background, so mainly like VMware technologies, and then focused more on the cloud solutions and Kubernetes, and also specifically in those areas like about on infrastructure as code solutions and on FinOps solutions, so how to save money in the cloud or in Kubernetes environments. And now mainly I'm architecting solutions for customers here at TerraSky with the rest of the team. And also I really love automation, so I also build a lot of automations, such as we'll talk about here in this webinar. And of course, I guess I was not here if I didn't like technology, so I am a technology lover, you know, gaming and stuff, so that's me. Enough about me, let's talk a little bit about TerraSky before we jump to the rest. So this is TerraSky. We have multiple branches around the globe. So we have a branch in New York, and Amsterdam, Vilnius, Kiev, and the main one in Tel Aviv. Let me just close this Zoom thing. Okay, never mind. So we have more than 500 customers. We have a lot of deployments around for our customers, more than 800 you see here, and we have actually more than 100 employees now, and all the branches that you see here. And we also won a few awards from AWS, HashiCorp, Google Cloud, Dell Technologies, and so on. I will not focus on that because this is not why we came here. And of course, I forgot to say that we were founded in 2008. We collaborate with many vendors, basically, the main ones, and also the ones we'll talk about in this webinar is HashiCorp, of course. We all love HashiCorp, and AWS, which, of course, I guess most of you, maybe all of you love AWS. So we are a big partner of both of those. We also have an HashiCorp ambassador, Lev, which is part of our team. So this is great, but we also work with other partners like Google Cloud, GCP, Portworx, and some security companies like Aqua and Snyk, and some others, but this is less relevant for this specific webinar. Also, our team has have many certifications. So in AWS certified, like solution architect, DevOps engineers, and all those kind of certifications. Kubernetes certified, so CKA, CKS, and other Kubernetes certification, and of course the HashiCorp certifications that there are there, and some other certifications, but I'm not going to focus on that. So let's jump to the actual thing we came here to talk about. So basically landing zone, how we do it as code. So before I actually want to talk to you about landing zone and how we approach this, I want to talk a little bit about the background. So what is landing zone, how it's built, and what are like the base components for building the landing zone. After that, I want to talk a little bit about the current solution. So how you deploy landing zone. So there are like a few solutions that comes from HashiCorp and AWS to deploy the actual solutions or the actual landing zone. But I also will mention the problems that we saw in those solutions. So like each solution is great, of course, but it has its own problems. And then at the end, I want to display or talk about our approach. So how we did it differently than AWS and HashiCorp to actually solve those problems and to deploy the landing zone as we see it. So now the background. So landing zone According to AWS, as you can see here, the quote from AWS is a solution that helps customers more quickly set up a secure multi-account AWS environment based on AWS best practices. So at the end, what is a landing zone? Up until a few years ago, a landing zone basically meant like a customer comes to AWS and requested, okay, AWS, I'm a big company, I need a landing zone, I need multi-account structure in AWS. And AWS said, okay, so we understand your needs. Now we will assign a solution architect to work with you, and he will ask you the questions and what do you need in the landing zone, which accounts, what are the roles of the accounts, what exactly needs to be deployed on the accounts, what are the guardrails or policies to define for this landing zone. And at the end, basically, this solution architect would build like this complete solution of multi-account environment with all the policies and all accounts and all best practices from AWS inside it. So as I said, up to a few years ago, this process was like half manual. So the solution architect needs to sit with the customer and understand his needs, and based on those needs to develop the specific CloudFormation templates, in this case, to actually deploy the landing zone. But then AWS realized that most customers have like, I don't know, maybe 80 or 90% of similar common ground for all landing zones, because basically all customers needs, the base thing should be the same for all of them. And then each customer adds its own customization or deploys its own security tools or whatever it needs. But like the common ground, the basic or the base things are the same for all customers. So AWS said, okay, if this is like a common thing, let's develop a solution that will do it easily. But before we talk about the solution that AWS developed, let's see a little bit about this, how this looks like. So what is the architecture of this multi-account landing zone solution? So I will not cover all the bullets here, but let's talk specifically about some of them. So first of all, of course, if you want to deploy a multi-account structure in AWS, the main thing that you need is to use the AWS organization service. So the AWS organization service is the service that basically allows you to create accounts or invite accounts to your organization, and also create policies like tag policies, service control policies, back policies, etc., and assign them to the accounts. And also there is like this middle layer of organizational units, which is like logical unit to segregate between accounts. So you can say, okay, these accounts are like production accounts, so they will be like in one production organizational unit or OU, and another set of accounts are like dev accounts, so they can be in another OU, which is called dev, and whatever. So this is what you can deploy. Another common thing in all landing zone solutions is using the AWS SSO. So the single sign-on basically allows the customers or the users inside the company of the customer to actually go and access those accounts. So let's say that I'm a developer inside the company and I need access to the production and the dev account. So the security team who manages the AWS SSO will provide me access with the specific permissions that I need to the specific accounts, which in this case, dev and the production, let's say. Just as an example, of course, no one should actually access the production account in real life, but let's just for this example, so the security team can say, okay, so this user or this group of users can access these accounts with these permissions and policies, or they call it permission sets, but let's stick with permissions. Apart from these, the common ground of common structure of landing zone consists of this core OU, as you can see here in the middle. So this core OU is like the OU that contains the basic or the best practice common accounts to create when you create this landing zone structure. So you have the security account. The security account contains all the security tools or components that are shared among multiple accounts. So of course, if you need some security component inside a specific account, like production account, and only to that one, then deploy it inside the account itself. But if you have something like global, for example, in this case, as you can see, the Amazon Guard Duty, then you can say that the security account will be the master of the Guard Duty for the organization, and then you will manage Guard Duty for all accounts inside one single account. And of course, you will provide the security teams access to this specific account so they can manage guard duty in this case. Apart from guard duty, the security account, according to AWS, should also be for the security teams to actually audit the account. That's why it's also called the audit account. So they can also access the security account and then run lambdas on all other accounts inside the organization. Basically, the idea is that all other accounts inside the organization will have a role that can be assumed from the security account. And using that role, the security members inside the security account can deploy or run lambdas on all the other accounts to, I don't know, deploy some automations or whatever is needed. Of course, this is not all. If you have any other security common solution that you need to deploy, you should deploy it in the security account. Okay, so apart from the security account or the audit account, as in some cases they call it, there is also the log archive account. So the log archive account is meant for actually archiving or collecting logs from all other accounts inside the organization. So basically all, let's say that people log in, or all the audit trail basically generates or collected by AWS should be sent to this log archive account so that you can view everything or all logs, all audit logs in one central location. So this is why the log archive account is used for. And of course, you give the relevant people or relevant teams in your company access to this account. And lastly, this is not an account that is like deployed by default with the AWS solutions to deploy the landing zone, but it's very common to have this shared services account. So we talked before about the security shared components that you might have, but if you have like other shared components, in this case, let's say that you have VPC and subnets that you want to create in one single location, then share it to all other accounts in the organization. You will do it in this shared services account. Of course, you can also create network account and do it from there. But basically, the idea is that if you have other components, like non-security components that are shared between multiple accounts, you create them in the shared services account. Another example can be, for example, Active Directory. So if you have Active Directory, which is shared to all other accounts, you can create it in the shared services account and then provide the relevant users access to that. As you can see here, apart from that, there is the account baseline, which basically defines what is like the baseline of all the accounts that are created inside the organization. And so this is deployed on all accounts and all other future accounts that will be deployed to this organization. So this is like the common thing of how we deploy the multi-account structure in AWS. And now let's talk a little bit about the current solutions. So as I said before, up until a few years, you had to like reach out to AWS to talk with the solution architect, of course, AWS or AWS partner, talk to a solution architect and define your exact needs and what he will talk to you about what you need and how the landing zone should look like. And then he will develop the CloudFormation templates to actually deploy this landing zone that you need. So since AWS saw that this is very common in most cases, the baseline of this deployment is pretty much the same. So they came up with the solution that's called Control Tower. Probably you heard about it because it's a very common solution. And basically, Control Tower gives you an automation to deploy everything we talked about before with a single click or maybe a few other clicks to deploy the rest of it. But basically, it gives you a very, very easy user interface to deploy everything we talked about before. So Control Tower, when you deploy Control Tower, you actually deploy the landing zone. So it's like one click, takes around 1 hour or something like that to deploy the common landing zone structure. So this audit security account, the log archive account, and the OUs and the SSO and all the rest that we talked about. So this is deployed with one click using Control Tower. But apart from that, you have some other things that are deployed with Control Tower by default. So you have the set of guardrails, which are basically a set of policies that are deployed to your organization to actually govern some security things, AWS things, or so that are like best practices. Those guardrails are like defined by two separate types of guardrails, let's say. So you have this guardrails that are deployed with service control policies, which are basically denying users inside the accounts to create or change some configuration. And there is the other type of guardrails, which are based on these config rules. So the config rules, if you're familiar with them, basically just collect information about the resources and tell you if you have something that is different than what you need, than what you configured. For example, for guardrails, you can have a guardrail that says, don't allow creation of S3 buckets with public access, which is, of course, this is a common best practice. So AWS said, okay, we want it to be like by default enabled when you deploy the control tower. And also you can have some other config rules deployed by default with control tower. For example, like show me all users that don't have MFA configured on them. So it will, this is using the config rules, and it will list you all the users without MFA configured. So guardrails is something that comes by default with control tower. Some of them are mandatory guardrails, so you cannot even disable them. And some of them like optional, that you can choose if you want to enable or disable, and to which account or use you want to enable or disable them. Apart from that, of course, you have the account factory. Account factory is where you actually provision the new accounts. So, okay, so you have the landing zone ready, but now you actually need your workload accounts to be provisioned. So the account factory is another thing that comes with control tower, which is basically using behind the scenes the AWS service catalog, but also some other services from AWS. And at the end, it is used to actually deploy the accounts, the workload accounts that you need to deploy in your environment, in your landing zone. And one of the main features of control tower is the UI. So you have a nice dashboard where you can see which accounts that you have currently in your environment, which are used, which guardrails are applied to which account. You can provision, of course, with account factory in the dashboard, new accounts to your landing zone. And another few features, of course, configure the landing zone with some basic configuration. And that's the UI. So if we talk a little bit about the benefits of control tower, so first of all, I think the UI is one of the main benefits of control tower. So you have that. You can easily deploy the landing zone with one click, as I said, like 1 hour, and then you have the landing zone ready. You can easily deploy multiple AWS accounts. So if you want to deploy, I don't know, 2 production accounts, just go to the UI and deploy them, and then dev accounts, go to the UI and deploy them, and so on. You have these predefined guardrails, which are really, really nice. That you have a set of like best practices, policies to actually govern your landing zone without you need to write those policies from scratch. And it relies on AWS services. So a control tower basically at the end is like a wrapper for a few different services, many services actually. So it's like a wrapper for AWS SSO, for AWS organizations, for AWS code pipeline and some other services. So at the end, it basically, you have this one single UI to manage those things, but it will actually run different services to provision the different things that you need to provision in your landing zone. So this is very nice, but there are some issues. First of all, it's hard to customize it. So I will also show you a slide later of how the customization works. But basically, if you want to customize the landing zone, then there is this package came with a control tower, which is called customizations for control tower. Sorry for that. So this package is a bit complex. Inside it, you have this manifest file, which you define which CloudFormation templates you want to deploy on which account. You can also define which policies you want to attach to which account or organizational unit. And you need to also push to this package. You also need to push all your CloudFormation templates that you want to deploy and the policies that you want to deploy as well. Then you need to package it in a specific way, in a specific structure that AWS provides you. And then you need to push this package to an S3 bucket, and after that, it will be deployed to the accounts. So it is possible, but it's complex. It takes some time, and the main issue, in my opinion, is it only supports CloudFormation. So if you're working with Terraform, then like most companies do, I hope at least, because I love Terraform and I think that most companies love Terraform. So basically this, you can use this, of course, if you want to write your CloudFormation templates now from scratch, then you can do it, but you cannot use Terraform in this customization. So this is actually bringing us to the second bullet, which is the customization of control tower only supports CloudFormation. So if you're a company that works with CloudFormation, then everything is great for you and probably you can do everything. So this is okay. But if you are like most companies and you work with Terraform mainly, then it's a problem for you. And then you can, basically the solution is not so good in your case. Another issue with control tower is that you can only define different networks. You cannot define different networks for each account. So this is like a small bullet, but actually I think it's important because when you provision accounts from control tower using this account factory, as we talked about before, you can define how your networking will look like. So you can define what will be the VPC CADR, how many public subnets you will have, how many private subnets you will have in each account, and a few other configurations. But the main problem is that this is the same for all accounts. So basically, if you provision 10 accounts, some of them prod, some of them dev, they will be all provisioned with the same VPC CADR, the same subnet CADR, and the same number of subnets, basically. So if you don't connect subnets or VPCs with like VPC peering or transit gateways, you will not have any problem with that. So everything is good in this case. But if you are like most customers and you need to connect in some cases your VPCs, I don't know, maybe dev to connect to other dev account or whatever use case that you have, because in some cases you do need to connect some subnets or some VPCs. You will not be able to do it. Because as you know, if you have the same CADR for two subnets, you cannot connect them with VPC peering or transit gateway, because then, of course, the packet will not know where to go. So this is a big problem, in my opinion. And another big problem is that there is no API for control tower. So if you want to actually provision an account from control tower, you can do it only through the UI. Now, as I said before, control tower is actually a wrapper to other AWS services. So in theory, you can go to the API of AWS organizations and go call the function to create an account through AWS organizations, which has an API. But the problem is that when you do it directly with the service that the control tower is a wrapper on, it will not be registered with control tower. So let's say that you do provision an account through AWS organization through the API, then you will need to go to control tower to the dashboard and actually register the account to control tower. And also, of course, you need to create some roles in the accounts, but this is easy. But the main problem is that you need to go to control tower UI and actually register this account to control tower. So there is still like UI intervention that you need to do. And I don't like it. Hopefully at some point there will be an API for control tower. I believe that there will be, but of course I don't have the exact estimation or if it will be at the end. Hopefully it will, but currently there is no API, so this is a problem in my opinion. Now we talked a little bit about this, how to customize control tower, and I talked about, as you can see here, the CFCP is customizations for control tower. Basically, this is how the customizations work. I will not go over this whole thing because this is not like the main purpose of this webinar, but I will just show you how complex the solution is, because if you want to customize a control tower, as I said, you need to create this package in a specific way, then upload it to S3. You can also use code commit if you want. Once the package is there, it will trigger a pipeline, which will trigger code build to build your build machine. And then it will trigger multiple step functions. And then actually it will deploy the CloudFormation templates to the accounts and assign the organizational policies to the accounts or use. So this whole solution is a bit complex. And the main problem is actually when I had to work with it for a customer that used CloudFormation actually, we had a problem in one of the steps. So we had to actually debug each of the steps to understand what was the problem, and then we actually, when we found out that the problem was with the build machine, we actually need to actually debug the specific build machine, which was very complex. So it's not like easy, like Terraform apply, and then you see what was the error, and that's it. Here you need to actually go through each step and see what was the problem and where it failed, and it was very complex. So that's why I'm saying that the customization in the native control tower is complex. So not only I thought about it, and actually a few months ago, Terraform or HashiCorp actually came up with a solution combined with AWS, which is called Account Factory for Terraform. So Account Factory for Terraform is basically meant for people who use Terraform regularly, and they want to provision their accounts inside AWS in their landing zone with Terraform, and also to provision resources on top of those accounts, like automatically when they are provisioned, when the account is deployed. Of course, this is where you can do it with a GitOps model, like you work with Terraform Cloud, for example. So you can like push the manifest or the Terraform module that deploys your account with resources to Git, and Terraform Cloud, Terraform Enterprise will take it and actually deploy the account. So this is very nice. It gives you the ability to use Terraform to actually deploy the accounts, which was one of the main points. And if we talk about the benefits of AFT, which gives a lot of benefits actually, so you can deploy multiple accounts using Terraform. So here in this case, you don't need to use the UI. You actually can go and just choose. You can create this module to deploy multiple accounts to Terraform. Just plain Terraform, and then you define your accounts. You define the resources on top of the accounts, and you just push it to Git, and it will deploy your accounts. You can customize the accounts, so you can say like I want these modules to be deployed on this account and these modules to be deployed on that account, and so on. It relies on AWS Control Tower behind the scenes, so they didn't actually invent like the whole thing from scratch. So they created some structure to actually rely on AWS Control Tower. And one of the good things is that it was deployed by HashiCorp, created by HashiCorp and AWS. So basically, that you have two big companies behind the solution, and I'm sure it will be developed more and more, and it will become better. But now I'm talking about the current solution that they have. But there are some issues. So first of all, this is a complex solution. Just to talk about, I will not go deeply into this solution, but I just want to tell you that, for example, to deploy the solution, you need to actually create 4 different Git repositories. One will be for the actual account modules. One will be for the global customization of the accounts. One will be for the specific customization of accounts, and the other one, which I don't actually remember exactly what it meant for, but basically you have 4 different repositories that you need to manage, and they are not built very simple. You need to build them in a specific structure. Another problem is that you cannot manage the infrastructure of the organization itself. So the AFT, Account Factory for Terraform, is meant to only deploy and manage accounts. You cannot create policies like SCPs, service control policies. You cannot create organizational units. So all those kind of things and other things of the organizational level will still need to be created manually in the organization. So if you need to replicate an organization, you will still need to go and manually create the policies they'll use and so on. And then the accounts can be deployed with AFT. Now, I also wrote here that it relies on AWS Control Tower. And this is because Control Tower has its own limits and has its own problems. So that's why, in my opinion at least, I think it was better to actually develop a solution that will not rely on Control Tower itself, but actually will do all the things using the backend services. And then you will also be able to create the SCPs they'll use and so on. So I think that this is a problem. Of course, people can say, okay, this is a good thing that it relies on Control Tower, but this is just my opinion. And another small thing that I wrote here, but I think is very important, is that let's say that you deployed, 100 accounts, and you have with AFT you deployed all the accounts and everything is great. Now the security team comes to you and says, okay, so we have like a new vulnerability and we want to make sure that all the accounts in the organization have a specific policy created in them. I don't know, something like that. Some specific thing that needs to be created on all accounts, but those accounts were already been deployed. So as you know, if it was like plain Terraform without control tower at the backend, you will just, just update the Terraform module that you have, run Terraform plan, apply, and that's it basically. In this case, this is not, although you write your Terraform in like Terraform HCL code, but the actual trigger, the actual deployment of the resources is done behind the scene with control tower. So with code pipeline and step functions and all this like complex structure. And this doesn't support actually an easy update of accounts. So if you did update your Terraform modules to update your accounts, you will actually need to go to the step functions and trigger them manually through the UI. I think this is like a big issue in my opinion, because the whole idea of infrastructure as code is that you do everything as code. You don't want to go to the UI and actually trigger things manually. So I hope that this thing will be solved soon. But currently, from our tests, you actually had to go manually to the UI and trigger those pipelines, and it was a bit complex, and I didn't like this. Of course, if you just want to create accounts with resources, there is no problem, and everything works like by the box. You just create the Terraform modules and push them. But as I said, if you want to update existing accounts, then there are problems with that. A little bit about the architecture of AFT, so how it looks like. So let's say that we have the developers or the DevOps engineers, and they actually commit the code to code commit. As I said, there are like 4 different repositories to commit the code to based on what you want to do, if it's like deploy a new account or deploy resources on the accounts themselves. Once they push the code, it will fill Amazon DynamoDB with the accounts that are going to be provisioned and with the resources that needs to be provisioned. And then it will call the service catalog to actually provision the account and control tower. The account will be created. Then a step function will be triggered to actually deploy the resources onto the accounts. So if it's like Terraform open source, which you're using, then the code build, the build machine will just call the Terraform module, but you can also use Terraform Cloud or Terraform Enterprise, and then the code build will trigger a workspace inside Terraform Cloud or Terraform Enterprise, and then it will deploy the resources on the account that you provision. So as you saw before that, there are some limitations and there are some issues with both solutions. So with like native or plain control tower, or also with AFT. So we thought here at Terraform, we thought about what we can do with it, because of course we can continue working with those solutions and probably they will be better in the future. But we wanted to develop something that will help our customers now this step, and we also want to look at it a bit differently than what we saw before that with AFT. So I want to introduce you with LAZE. LAZE is just a name that we invented. Basically, the whole idea of this solution is to have your entire landing zone as code. So no UI at all. So you don't need to go. I mean, for people who like the UI, this is a problem maybe. But for those of you who just like, terminal and just code all the time, so this is great. Basically, the idea is that you have all the landing zone defined as code with Terraform, of course. It's developed to handle these common customers requests that we have for landing zone. So like every once in a while, a new customer comes to us and says, okay, I want your help to deploy landing zone. So should they use control tower? Should they use AFT? Should they do it manually? What should they do? So because we saw, and also most of the customers have the same needs at the end, or basically the common same needs that they need. So we wanted to have some automation that will help those customers and will help us at the end to deploy this landing zone and their environments, and to manage it after that, of course, like data operations and not only the first deployment. This is an alternative to AFT and Control Tower. So if you are using LAZE, you will not use Control Tower or AFT. This is like, if you are using LAZE, it interacts directly with AWS services and not with Control Tower, mainly because there is no API for Control Tower, because if there was, we might have used their API or their provider for Terraform in some cases. And the idea is that you define your entire AWS organization. So not only accounts, but also policies like service control policies or tag policies or backup policies. And also all the resources will be deployed on those accounts with just YAML files. So it becomes very, very simple to deploy your organization and also very simple to update your organization. So you don't have any manual things that you need to do. Of course, except for just creating the management account of the organization. This is the only thing that you need to do. And once you have that one, and you have access to that through the like a user with permissions and access key and secret key, you can use LAZE to deploy your entire organization. And LAZE, lastly, it's based on CDK for Terraform. We used it because it was very convenient to us to write the backend of this solution with CDK for Terraform. It's a really great solution. When we started with it, it was on version 0.4, I think, and now it was developed since then. But it's really, I think, it might be like the future. Many people might use CDK for Terraform, and I highly recommend you to check the project out and to see what the capabilities of it. So some comparison between Control Tower and LAZE. So first of all, and the most important thing is that with LAZE, you can deploy your entire organization as code, as we said before. And of course, it's not possible with Control Tower. You have the UI to do those kind of things. With both of them, you can create the organization itself. So like the organization object. In LAZE, we also support the creation of the alias of the management account. So this is maybe a small thing, but it's another thing that is supported by LAZE. You can define what will be the account alias, the IAM alias, if you're familiar with it, of the management account. You can set global tags to all resources inside the organization with LAZE. This is not supported with Control Tower. And this is cool because if you know with Terraform, you have this provider default tags, for example, for AWS. So we use this concept to actually deploy all resources, so accounts, organization units, policies, and all resources inside the accounts. And if you want, you can have these global tags that will be assigned to all of them. For example, if you want to have a tag with Terraform true, for example, you can assign it once in the YAML file, and it will be assigned to all the resources inside the organization. So this is very cool. And both of them support the creation of the management accounts, the audit and log archive accounts. But in Control Tower, you must have them in different accounts. In LAZE, we also added the possibility, the option to actually deploy those both roles in one single account. Of course, in big organization, you will want to spread them or separate them between two accounts. But if you are like a small organization that want to test the landing zone, then you might consider putting them in the same account. In LAZE, we can create custom organizational policies. So with Control Tower, you can do it only for SCPs with the customization for Control Tower. But with LAZE, you can also create tag policies and backup policies. So LAZE basically supports all types of organizational policies. In both, you can create custom OUs. In both, you can create nest OUs. By the way, in Control Tower, this was not an option up until a few months ago. They added the support for nested OUs a few months ago, but now it's supported anyway. In both, you can attach policies to OUs. In both, you can create custom AWS accounts. In both, you can attach policies directly to AWS accounts. And another big advantage of LAZE is that you can define each account with different networks. So if you remember, we said about Control Tower that when you create multiple accounts, they are all provisioned with the same network. With LAZE, you can define what will be the CADR and what will be the subnet in each of the accounts that you want, so that you can make sure that you will not have the same CADR for both of the accounts, and then you can connect between them or do whatever you need. And I think maybe the biggest advantage of LAZE is that you can actually define which Terraform modules will be deployed on the accounts after they will be deployed. So as we said before, with control tower, it's not possible. You have only the customization for control tower only supports CloudFormation customization. With LAZE, you can actually specify which Terraform modules you want to deploy on which accounts, and like plain Terraform will be deployed directly on the account. So this is very easy, and I will show it in the demo. And lastly, currently control tower supports these default guardrails, which are great. LAZE doesn't support it yet, but it will be very, very soon. So stay tuned. Here is an example of like very, very simple organization that you can deploy with LAZE with one single YAML file and one command. So let's say that we want to deploy this security OU with two accounts that we talked about before, the audit or security account, log archive account. In addition, we want to deploy another OU, which is called prod, with another account inside it, which is called project A. This account should contain one VPC with 3 public subnets, 3 private subnets, one EKS module, and one EMR module. We want to also deploy another OU, which is called dev, with another account, which is called project A dev, and maybe a smaller VPC with just one public subnet and one private subnet. And the EKS module, let's say that we don't want the EMR module to deploy, that we don't want the EMR module to be deployed on this dev account, so we just deploy the EKS module. And on top of that, we want to have 2 policies deployed to the organization. One policy will be assigned to both OUs, and another policy will be assigned directly to one of the accounts, because I don't know, maybe it's a more secure policy for the production. So this whole thing is very, very simple example, but you can deploy this and much more complex things with LAZE with just single YAML file, and I will show it to you now. So let's go to the demo. Let me share this screen. Okay, maybe I will make it a bit bigger. Actually, I don't find. Never mind. I hope that you can see. If you can write if you can see the screen, the visuals to the code itself. Okay, yeah, great. So okay, so this is like an example YAML that you can define to actually deploy organization with LAZE. So let's go over what we have here. First of all, we want to define in which regions all the resources will be deployed. So in this case, I just choose North Virginia just for this example. And if we are working using like I'm working using my terminal, I don't deploy it currently with Terraform Cloud, so I define which profile, the best profile I want to use. So this is the name of the profile. I can choose if I want to create an organization or not. So I can choose if I want to, if there is already an organization created inside this main account, I can just choose false here and it will use this organization. But if not, I can just choose true. If it's like a brand new account, of course, I want to create an organization. I can set the root account alias. So as we said before, the IAM alias for the management account, I can set it here and it will set it to the account. Here I can define the key value pairs for the global tags. These tags, in this case, environment test and owner Daniel Vaknin, and they will be assigned to all resources, like all policies, all accounts, all OUs, all resources, everything will have those specific tags. Of course, I can add more tags to the specific resources themselves, but if I want some tags to be defined globally, I can do it from here. Here, this is a list of policies that we can define. Basically, a list of policies that will be deployed to the organization. So there are 2 ways to create those policies. One way is like this. Basically, I define a policy inline. So I'm saying this is the name of the policy. This is the type of the policy. In this case, it's SCP, but it can be tag policy or backup policy. And I can provide the content of the policy inline here. Another option is just to provide it from a file. So I just give the path of the file here, and then the policy will be created from this specific file. Then we have a list of OUs. So if I want to create multiple organizational units, then I will have this, I can create those OUs from here. So first of all, I create the security OU. Then I create the production OU. I can also choose which policies to assign to it. So I can assign both policies created before that. Then I create the dev OU. Here I can see I can assign specific policies to that one. I can also create nested OUs. So in this case, I create a prod nested OU, and I have the parent OU, which is called prod. And I can also actually let me revert this because this file was changed. So yeah, so okay. So this is for in the demo. I will deploy those parts that are commented out. So we will see it in the demo itself. But now I just want to go over the structure of the file. Okay, so then we have the accounts. This is one of the main things inside this file. Basically, I can define which accounts I want to provision inside my landing zone. So in this case, I want to provision the audit account, and I give it like a predefined role, which is called audit. As I told you before, you can have both roles on the same account, and you can have them separated, as in this case. So in this case, I'm creating also the log archive account with the role of log archive, and then I go to the the workload accounts. So in this case, this account, for example, I'm creating an account which is called LAZE project 01 with an email. I'm specifying in which organizational unit I want this account to be part of, which policies I want to assign to the account, if I want policy to be assigned directly to the account, and then the network. So I can, if I want to deploy VPC on the account from this configuration, I can choose create a network. I can choose the name of the VPC that I want to create, the CIDR, and the public subnets that I want to create in the private subnet. So as you can see here, I can have multiple accounts with different CIDRs, and each one will be created, and then you can connect between those VPCs or between those subnets with VPC peering or transit gateways. So I can specify here, as I push here, like multiple accounts, as you can see here. So I create multiple accounts and another account from here inside different OUs. This is just the same thing with different configuration. And now the last part of this file is TF modules. So this is like the main advantage of LAZE in this case, which is basically if I want to deploy Terraform modules directly on the accounts when they are provisioned. So to customize the accounts with Terraform modules. So this is how I do it. Basically, I put here a list of Terraform modules that I want to deploy. I give a logical name to the module. This is not the name of the resource, just a name to relate to this module in this configuration. I give the source of the module. So the source can be from Terraform registry, it can be from Terraform cloud, it can be from local file system, it can be whatever source from Git, of course, whatever source that Terraform supports, LAZE also supports. And of course, if this is from Terraform registry, it's very important to specify the version. So in this case, it is from Terraform registry. I'm deploying an S3 bucket. So I'm defining here the version. And then I provide the variables that I want to pass to this module. So in this case, I want this S3 bucket to be created with this prefix and the ACL to be private and the list of accounts. So which accounts should have this Terraform module deployed on? So in this case, I want these 5 accounts to have this module on. I can specify multiple modules to be deployed. So in this case, I create another S3 bucket, same configuration, but deployed on different accounts. And basically that's it. So let's now actually do the demo. So in the demo, what I want to do, okay, so first of all, I want to tell you that this whole thing was already deployed because it takes some time until Terraform deploys the entire organization and the accounts and the resources on top of them. So it takes some time. So I already deployed the organization. But in this demo, I want to show you how I can actually update it. So create another account and deploy resources on top of that account. So for that, I already commented it here, so it will be easier for me, but it's not yet created, and I will also show it in the demo. So first of all, I want to have this. So I want to create another new OU, which will be part of the dev OU, and the OU name will be dev project A. Then I want to create an account, which is this one. It will be called LAZE project 06, just to make it easy. It will be created in this OU that I specified before that. It will have a specific SCP assigned to it directly. And it will be created with a specific VPC and subnets, which are these CIDRs, as you can see here. The VPC will be called VPC project A. This is the CIDR it will create for the VPC, and these are the subnets. In addition to that, I also want to deploy a Terraform module on this account. So I want to actually deploy a module that creates an IAM user on top of this account. Just for this example, I provide the name of this module. For this module, I provide the version of this module because it comes from Terraform registry, and as I said, it's always recommended to have the version set. And I provide the variables. So the IAM user in this case will be called project A user. I also don't create an access key and a user login profile because this is just a demo, and I just want to show you the user that was created. But of course, I can provide whatever variables that I need for this module. And I choose to deploy it on this specific account that we specified before. So LAZE project 06. Now, because this takes some time to deploy, I actually prepared a video that will show you the deployment. So let me open that. Just a second, let me see. Okay. Okay. So I hope that you see. And let's see. So as you can see here, the dev OU doesn't have the OU that we created, that we specified to create, which is called, if we go back to the configuration, we specified the OU name to be dev project A. So we don't have this OU created. So I can go on. So now we go to actually deploy this configuration. So how we deploy? So first of all, we run CDKTF diff. This command is like Terraform plant. Basically, it will check the current configuration and check the configuration in the cloud. In this case, it will also check whatever we wrote in the LAZE application. So it will also validate the configuration, as you can see here. It will also validate the configuration for the organization unit dev project A, validate the configuration for the account, validate the configuration for the Terraform module that we specified, and it will start actually plan this deployment. So if I make it a bit faster because it takes some time, so it will plan the whole thing. Yeah. Okay, yeah, so this is where it finished the planning. Let's maybe put it like this. Okay, so what we have here, so we see that this is the plan results when we use CDKTF or CDK for Terraform. Basically, we see the plan results here. So what will be created? An organizational account will be created. An organization unit will be created. The policy attachment, because we chose to apply a policy to the account. Many network resources, as you can see here. So the route table, the public subnets, the internet gateway, the NAT gateway, whatever we defined in the network configuration. So all this will be deployed on top of the account. And at the end, we also see that the creation of the IAM user and access key and whatever we define there will be created also on top of the account. So you can, if you ignore the log archive module, this is just like leftovers from previous runs. And if we want CDKTF deploy, this is like the actual Terraform apply. So it will do the same thing. It will again validate all the configuration. It will again plan this whole thing. So let me just make it faster. Let's see where it ends. Okay, yeah. So here is again the same result, basically as we saw in the plan. So as you can see here, the same account, the resources will be created, and now we choose that we want to provision these resources. Now I will jump to the AWS console. Let's say that it was done. Let's refresh the page because it takes a lot of time to provision the accounts. But as we can see here, now under the dev OU, we have this dev project A OU, which was created, and the LAZE project 06 account, which was created. Let's see the policy. So we see that the policy was attached directly to this account as we defined there. Let's grab the account ID and let's actually switch the role to this account so that we see the IAM user. So I'm using the role that was created by default. I'm switching to the account. And let's first go to the VPC to see the VPC that was created. So the VPC should be with the 30.0.0 CIDR. So as you can see here, we have VPC project A with 30.0.0. And we can see all the subnets that we defined in the YAML file, also created here, the same with 30.0, whatever we defined. Of course, the internet gateway, route tables, and so on. And if we go to IAM, we can see now the user that we defined to be created with the Terraform module. As you can see here, project A user was created on the account by default when it was provisioned. So let's get back to the presentation. So as you saw, basically, the whole idea of LAZE is that you manage your entire organization through just a single YAML file. And of course, your Terraform modules that you want to deploy on the accounts. But it makes your deployment and management of the organization very, very simple. And I really hope that this was informative. And that's it, basically. Do you have any question? We have time for one question, I see. So, okay, I see one question. Oh, this is a good question. So why did we use Terraform CDK for this? Okay, so this is a great question. And actually, at the beginning, we planned to use just native Terraform, HCL language to actually create LAZE solution, just create like Terraform module to create it. But the main problem is that with Terraform, like plain Terraform, you cannot create loop of providers. So imagine in this case, what we are doing basically with LAZE is we deploy multiple accounts, and in the same plan, the same time, we also deploy resources on the accounts. With plain Terraform, if you have multiple accounts, like dynamic amount of accounts, and you don't know them beforehand, you cannot do it because there is no like for each or looping for providers. There is still an open issue on that, unfortunately. Hopefully it will be available soon, but as of now, there is no option to loop through providers. So you need to hard code the alias of each provider. And basically it becomes impossible to do it with just plain Terraform. Of course, there is an option to template this provider file, and then create it on demand. But we didn't like the solution. So we just went to use Terraform CDK. And with CDK, just plain coding language. So it's very easy to create a loop and create the providers on demand. You don't have any limitation there. So it becomes very, very simple to manage multiple providers and multiple dynamic providers, which in this case we need. Yeah, so, okay, so I hope that this was good. I hope it was informative. And of course, reach us out if you want more details about LAZE or landing zone or whatever you want regarding Terraform, Control Tower, AWS. This is my email address. We are TerraSky, and thank you very much for listening.